you guys for coming for the next speech, and we will welcome Igor Gulamov, and he's going to give a talk about solving Vitalik's trilemma with the ZK-driven DA and storage. Welcome.
Hi. So I will tell you about our solution of Vitalik's trilemma with ZK-driven data availability and storage. So what is Vitalik trilemma? We have three properties. Oh, it looks like technical issues happens. OK. Now it's better. So, OK, what is happening? It's blinking. What does mean Vitalik trilemma? It's not corresponding what I'm showing on the screen. OK. OK. So what does mean Vitalik's trilemma? We have three properties of decentralized ledger. It's scalability, security, and decentralization. And the trilemma means that we can select only two of three. Why the solution of Vitalik's trilemma is important? Because we need for mass adoption scalability, especially for migrating from Web 2 to Web 3. You know solutions like Forecaster, which need a lot of storage, transactions, and so on, and with very low costs. So that's why we need the solution of Vitalik's trilemma to make possible another more heavy solutions, not only decentralized Twitter, but decentralized Instagram, Facebook, and maybe YouTube. The historical review of this solution is the first. It was multi-chain ecosystem proposed by Polkadot and Cosmos. The idea is that there is core engine on which multiple blockchains could be implemented, and these solutions can use this core engine for interchain communications. Next, it was Plasma, based on game theory. And if something is going wrong, anybody can start the game in which he can win it and get his assets back. Next, it was evolution of Plasma. It is optimistic rollup, ZK rollups, and ZK validiums. And the most fresh solution is data availability layer. It's implemented in Ethereum, in Protodunk sharding, and also there are solutions like Celestia, Agent Layer, and Avail, who provide data availability also. The issue of data availability is that the data is stored for a short time. It could be 2 weeks or 1 month. And these things are originated from Plasma when it is enough to observe the operator during 2 weeks. And then if you have some assets or something else, you can save the data you needed, and then you can make transactions with this data. Why rollups are not enough for solving the Vitalik's trilemma? Because rollups don't scale the data. So here is how rollup is working. We have L2 with state transition proofs. But also we have the data, and we should publish the data with high soundness way, because all users need this data to make transactions. Users cannot make transactions for rollup if they have no data. Also, that's why we cannot deploy rollups into rollups and so on, because the data is floating up. The data is floating from L2 to L1. Before dunk sharding, it was stored in cold data. Now it is using dunk sharding, and it also could be used in other data availability solutions. But anyway, this is a bottleneck. And also, the current data availability solutions are storing the data just small time frame, and the next, the users should store the data by themselves, or they should trust any off-chain infrastructure third parties who do it. We need recursive rollups to solve Vitalik trilemma, and we need to solve this issue of floating up the data. Our approach is data-centric solutions. The current solutions are Filecoin, R-Wave, and DA&Storage. They use data availability sampling for proof that the data is stored and available. Also, miners can mine the rewards using the data stored by nodes. To solve the Vitalik's trilemma, we need some improvements. The first is using read-Solomon codes for more than 10 times better storage utilization, because current solutions are using replication. And what does it mean? That means that if we need high soundness storage for the data, we need to make a lot of copies of this data and hope that at least one of these copies will be alive. And then the data is stored and available. With read-Solomon codes, we can mix all the data together and make blow up. And then, if any source amount of new blown up data is available, then we can reconstruct the source data. It is much more efficient solution than just replication, and we can reach more soundness on it. The next one thing is wall chain provable ZK proof. It's possible, it's shown by Mina blockchain that we can do a lot of state transitions, consensus-related things, and so on, and we can compress this all into one single proof. In our research, we've shown that all data-specific things we needed for data-centric blockchain functionality, it's possible to prove with ZK snarks in one single proof, and it is working like ZK data availability and storage oracle. And this is a very useful thing if we need to solve Vitalik's trilemma and build a recursive rollup system. Speaking about read-Solomon codes and its efficiency, here is how it's working. Let we have 4 numbers. We can encode it as a 3-degree polynomial, like this. Then we can make blow up. We find another points. Then, for example, if we forget some part of this data, now we have another points, but any 4 points are enough for fixed degree 3 polynomial, and that's why we can recover the source data. And this is much more efficient than just to take these 4 points and make a lot of copies of it and hope that each point is present at least one time. Because if the scope of data is large, there will be high probability that at least one point will be lost. And that's why Reed-Solomon codes are better, because we can prove that all data is safe. Speaking about Reed-Solomon codes, the important problem is how to prove to all data storage nodes that their shards are correct. And we can do it with polynomial commitments. So we have polynomial commitment to source data, and we can make this polynomial equation to prove that commitment of the shard for each node is correct, Reed-Solomon shard. That's why all nodes could be ensured that they receive the right chunk of data, and that's why anybody can collect sum of shards, any subset of these shards. We use blow up factor 8. It is 64 to 512. So if anybody collect 64 shards from 512 shards, they can reconstruct the source data. Here, how data-centric rollup is working. We have data storage network, L2, L1. So the idea is that we can make zero-knowledge proofs that the data is stored and available. We can do it because we can prove with snarks all process related to storage and availability of data, including state transitions and random data availability samplings, and mining of nodes, and so on. So we can make zero-knowledge proofs that the data is stored and available, and we can join it with a rollup execution proof. And by this way, we can construct the proof with state transition and data availability inside. And when we publish this proof on chain, we don't need additional things like floating up the blocks. Because with this proof, we already know that the data is stored and available, and users can use it. So here are some parameters of such rollup. The capacity is more than 1 petabyte. The soundness is more than 110 bits. That means that if half of network is malicious, then the data could be lost with probability to in order minus 110, very low number. And the cost, if the node is Hetzner node, is 15 cents per gigabyte per year. It's including 8-time blowup already. In specialized rigs for storage, the cost could be lower. And recursion is unlocked because this rollup provides data for itself. That means that such rollup could be deployed inside rollup, and we don't need to float up any blocks, and we can build decentralized infrastructure of rollups. Next, could we reach more scalability? The answer is yes, because we unlocked recursive rollups. We can build a network of rollups providing infinite scalable system. Only one overhead here is that we need to manage mining nodes on top layer to prevent concentration of malicious nodes in one single segment of the network. We have modeled all this situation, and we have strict proof that this soundness estimation is valid for asymptotic infinite scalable system with such architecture. How it could be reached? When somebody left from the pool, we should find the replacement node. And also, we make 2 random mixings. And this is enough to prevent concentration of malicious nodes in one single rollup. And that's why we can build infinite scalable system like this. Here are some links for our research. I think solution of Vitalik's trilemma is important for migration from Web 2 to Web 3, not only decentralized Twitter, but decentralized Uber, decentralized Instagram, decentralized Facebook, and so on. And of course, it's important for general purpose blockchain-specific problems also. Thank you for your attention.
Thank you, Igor. Do we have questions? Silence. No questions. Thank you very much. Thank you for your presentation, and thank you for your attention. If you're attending any side events, please go. And tomorrow we start here 10:30. See you back then. Thank you.